Have you ever seen a poll and wondered how in the world they can claim to know what an entire country thinks just by asking 1,000 people? Or how a company figures out the average price of a product without checking every single store? Well, today we're going to pull back the curtain on the powerful statistical tool that makes all of this possible: estimation.
So here's the core problem we're always up against. We want to know something about a massive group, what we call a population, but actually measuring every single person or thing in that group is, well, it's pretty much impossible. It's too expensive, it would take forever. Let's make this super concrete. Imagine you're a publisher, and you want to know the average price of all the competing textbooks out there. You can't possibly find every single one. That's a giant unknowable number. So what do? Where do you even begin? The answer, the really clever solution, is we estimate. We take a small, manageable piece of the whole puzzle, what we call a sample, and we use that little piece to make an intelligent, calculated statement about the entire picture. And the process itself, it's actually surprisingly straightforward. It's kind of like a 4-step recipe. First, you pick a random sample. Then you collect your data from that sample. Third, you calculate a key number, like the average. And finally, you use that one result to make a claim about the entire population. So let's start with the most basic, most intuitive way to estimate. If you could only give one single number as your best guess, what would it be? This is what statisticians call a point estimate. It's just that, a single point. It's the one value from our sample that we're going to use as our best guess for the real value of the whole population. Think of it like putting a single pin on a massive map and saying, I think the treasure is right here. So back to our textbook example. Let's say we took a sample of 25 textbooks and found that their average price was $145. That number, $145, that's our point estimate. It's our single best guess for the average price of all the textbooks out there. Simple, right? But is it really enough? Because here's the catch. Relying on just one number, no matter how carefully you calculated it, has a really big, fundamental flaw. I mean, just think about it. What if we took a different sample of 25 books? Would we get exactly $145 again? No way. Almost zero chance. We might get $142, maybe $151. Every sample is going to be a little bit different just due to random luck. So a single point estimate doesn't tell us a thing about how much uncertainty is baked into our guess. And this leads us to a much, much better way of doing things, the interval estimate. Instead of just saying $145, we create a range of plausible values. Something like, we think the true average is probably somewhere between $133.45 and $156.55. It's just a more honest approach, right? Because it openly admits that we don't know the exact number. This powerful range is called a confidence interval. And let me tell you, it's one of the most important concepts in all of statistics. It's what lets us move from just a simple guess to a truly confident claim. So a confidence interval is basically this range that we build around our point estimate. But it comes with a super important sidekick, a confidence level. And that tells us exactly how much faith we should have in the method we use to create that range in the first place. The basic formula for it is really simple. You take your point estimate, your best guess, and then you add and subtract something called the margin of error. You can think of this margin of error as a safety buffer, a little cushion that accounts for the random luck of which specific sample you happen to pick. And that confidence level you usually see 90%, 95%, or 99%. It tells us how often our method works. So a 95% confidence level means that if we were to do this whole thing 100 times with 100 different samples, 95 of the intervals we created would successfully capture the true, real value. It's a statement of confidence in our process. Okay, enough theory. Theory is great, but let's make this real. Let's look at an actual study that was done for the Center for a New American Dream. All right, so they surveyed over 1,800 American adults, and their point estimate, their single best guess, was that 75% of them said having basic needs met is a key part of their vision for the American dream. But of course, the researchers didn't just stop there. They also calculated their margin of error. And for this survey, with a very high 99% confidence level, the margin of error was plus or minus 2.6%. So now you just do the simple math. You take 75% minus 2.6%, which gets you 72.4%. Then you take 75% plus 2.6%, which is 77.6%. And that gives us our final powerful statement. We are 99% confident that the true percentage for all American adults falls somewhere in that range. See how much more informative and useful that is than just saying 75%?
Now, all of this probably has you thinking about a really practical question. If taking a sample gives us an estimate, how big of a sample do we actually need?
I mean, this is the million-dollar question for every researcher, right? How many people do I need to talk to, or how many products do I have to test to get an estimate that I can actually trust and make decisions with?
And here's the fundamental trade-off. If you want a more precise estimate, which means you want a smaller, tighter margin of error, you really only have two choices. You can increase your sample size, which costs a lot more time and money, or you can lower your confidence level and be a little less sure about your result. There is no free lunch in statistics. You always have to trade something to get more precision.
So why does any of this matter to you? Well, because understanding this one core concept can totally change how you see and interpret the world of numbers that you see every single day. I absolutely love this way of putting it. A confidence interval is an honest statement. It's not pretending to have the exact perfect answer. Instead, it quantifies our uncertainty. It actually embraces what we don't know in order to make a powerful and reliable claim about what we do know. So the next time you see a news report about a political poll or a new scientific study, don't just look at the big headline number. Look for the fine print. Look for the margin of error. Look for the confidence level. Because now you know the real story, the honest story, is hiding inside that range. What will you see differently?